Okay, so many of you have questions or difficulty with this number 5 problem of summing 3. So I'm gonna just talk about it here, okay? Actually, there's some hints here. So see this example, lecture 8, and example 2, lecture 9. So in example number 3, example 3 of 8, in that particular example, what one of the I think what was that? Oh, right. It's basically if x of t give y of t, okay, for LTI system, then dx over dt give dy over dt. Okay, that's this example. And for this example here, right, in that example here, x of t basically is a unit step function, right, and it gives certain y of t. Then we're looking for impulse response. The definition of impulse response is the impulse is a responsive system when the input is delta t. So we take a derivative of this, which is du over dt, which happen to be delta t, and that, based on this here, produce dy over dt. And delta t is the input, so that's why the output here is called the impulse response, right? So basically, the conclusion, of course, you don't confuse yourself. The conclusion is not that impulse response equal to dy over dt for any general output, and only for this particular case, because the input is u of t here. Okay, that's only for this particular case. Okay, so for this question here, we want to know what's h of t. The definition, of course, is a delta t produce h of t. Right, so that's the definition for impulse response. Okay, and the question gives you the x of t, okay, which give output x y of t, and then it also tells you when input is dx over dt, the output is this. So I guess we probably first step is to take what's the derivative of dx over dt, right? You already have x of t. So you need to calculate this one first. Okay. X of t is this, okay, and there are two time functions. Use product rule to calculate the derivative of this, okay, so 2 use product rule. Yeah, and then the second one here is du of t minus 4, right? Okay, so what's this one here? We know that delta t equal to du over dt. So this guy here actually will give us delta of t minus 4, right? Okay. In assignment number 2, and I have asked you to do some simplifications when the function is multiplied with a delta function. So in this particular case, we replace the t at here with 4, right? Because this function exists only at t equal to 4. Okay? And now, before we go ahead, look at this one here, right? Negative 2, an expression. So what is this? Right? That's exactly, you look at your expression x of t, that's exactly your x of t at here. Okay? So basically, this one equal to 2 x of t plus e to the power of a negative 2 multiplied by 4 plus 3, which is negative 5. Okay, so that's dx over dt. Okay, so what does this produce? Right, this guy produce, according to the given question, produce negative 2y of t plus e this. So it produced this. Okay. Okay, so let's take a look at observation here. So this expression produce this output. Okay, this input produce this output. And we also know that x of t produce y of t. So watch the first term here. So x of t produce y of t, which means -2 x over t produce -2 y of t, right? Linear time invariant system. So basically, you see the first, okay, the first quantity there, right? This guy here, right? This produced this. If this produced this and the whole thing produced that, that means what? The second term produced this one here. So which means e to the power of 5 delta t minus 4 will, when the input is this, it will give an output of this. Okay, so when input is this, it will give an output of this. Okay, yeah. Well, we're getting pretty close now because we are looking for this. Okay, which is h of t. We're looking for this. And we got this now. And that's just a shifted of delta t. And this is constant. So it's time to make use of the linear time invariant system property. Okay, so here's I'm going in detail. If I let wt, okay, equal to this, okay, so which means wt give an output of this, all right, according to time invariance property, which means when the input, right, time invariant property, the way we write is x t minus t naught give y of t minus t naught, right? Okay, now let's do this. Okay, yeah, normally we shift to the right, but in this case I'm doing this. What would the wt plus 4 produce? So w of t produced this, so what would the wt plus 4 produce, right? According to this time invariant property, this is shifted, basically shifted. So what happened? So we're gonna change the t, the output here, the output t here is changed to t minus t naught, so this t out here going to have to be changed to t plus 4. So this is going to be changed to t plus 4, don't forget that. So wt plus 4 will produce this. And this is because of time invariance property, right? Time invariance property. All right. But what is wt plus 4? Wt is this, right? Wt is this. So wt plus 4, basically, you're going to replace the t at here with t plus 4. There's no t here, but there's a t here. So replace this t with t plus 4. Well, t plus 4 minus 4 is t. Okay, so now we have is e to the power negative 5 delta t produce this output at here. But we're very close now. We're looking for this, right? Now let's try homogeneous property. Homogeneous property says when the input is cx, the output is cy. Okay, so let's just say this is another function. Let's call it maybe let's call it v of t. Okay, yeah, v of t gives this. Now I'm gonna try to get rid of this, right? So let's see, what does e to the power of 5 v of t produce? Right, this is a constant, basically that's a c here. So e to the power of v. So then the output, right, should also multiply by e to the power of 5. Okay. What is e to the power of 5 multiplied v or multiply this? And that's basically equal to delta t. So delta t produced this. Little simplification, e to the power of negative t plus 1 of this. And basically it's the same as my answer there. So delta t produced this. Basically, that means this is your impulse response. Okay, so that's the conclusion here. Okay, so what happens at here is actually a couple of applications. Okay, conclusions. Number one, we made use of this. Okay, number two, we make use of such kind of things. Number three, we made use of simplification in here. And most importantly, we made use of the properties of time invariance and the homogeneous property here, homogeneity. Okay, so that's a pretty that's a question sort of combined all the knowledge points at here, and also its application of many concepts at here. Okay, so take a look at this, fully understand the concepts behind each one step at here. All right, thank you.